right, so we're starting with the bottom of worksheet 1, or the back of worksheet 1. We're going to finish up graphing linear equations real quick. Anybody know what kind of an equation this is when it just says x equals 2? It is a vertical line. Good job. If this is how I try to explain it, it means all the x values are 2. Does that kind of make sense? No matter what the y is. So it could be a 0, it could be a 3, it could be a -5. Doesn't matter. It says x is always 2. So if I go to 0, to 3, to -5, you notice I get a vertical line. These took me forever to memorize and learn when I was a student. I do kind of remember it now by the fact that it crosses the x-axis at 2. It doesn't run parallel to the x. All right, number 13, we're going to talk about graphing a different way. Could you solve for y? Subtract the x over, divide everything by 2, and get it in slope-intercept form. This is called standard form, and we're going to talk quite a bit about standard form today. Standard form is ax plus by equals c form. It's really some silly form that a math teacher made up because some math teacher decided that we don't want fractions. We want it to look really pretty. So standard form can't have any fractions. It can't have any decimals. Whatever's in front of the x has to be positive. It's just a pain in the neck. Okay? But the only good thing about this form, in my opinion, is that it's easy to graph with the intercepts. If you want to graph by x and y intercepts, you try putting a 0 in for x and a 0 in for y. So what would this equation look like if I put a 0 in for x? It would just say 2y equals 6, and we'd get 3. What if I put the 0 in for the y? Even easier, it would just say x equals 6. So 0, 3, and 6, 0 are the intercepts. And, ooh, well, I hit the dots. They're just a really crooked line. Okay, so that should be the same equation you would have graphed if you had gotten the y by itself. You would have had something like this, -1/2 x plus 3, started up here, down 2/1, down 2/1. Does that look like the same thing you would have gotten if you get it that way? Okay. I don't care which way you used. The one on the quiz, I think, is in standard form. So if you don't want to mess with rearranging it, you could use intercepts. All I'm going to grade is, did you graph it correctly? Does that make sense? Whatever way you want. All right, so 14 could be rewritten as 0x minus 3 if we wanted slope-intercept form. What kind of line is it? Don't tell me straight. Horizontal, good job. They're all straight. Yeah, not when I draw them, but... All right, so there's a horizontal line that crosses the y-axis at -3. It runs perpendicular to the y-axis. All right, we could try this one rearranging or the intercept method. I probably would have rearranged that one just because it's easy, but if we put a 0 in for x, it would say -y equals -3. I think this, you guys don't have as much experience with this method, so I'll do this one real fast, which would mean what? +3. If I put the y is 0, so this became a 0, it would just say x equals -3. So over 0 and up 3, -3, 0, looks like this. If we had rearranged it, it would have said y equals x plus 3, which is the same thing. Any questions? Finish that guy up? Okay, you don't have this example, but we're going to do some like this off of worksheet 3 in just a second. So you get to put your pencil down if you want, or you can scribble this somewhere on your notes if you want an extra example. But we're going to multiply through by a common denominator. The reason for that is, do you remember doing some goofy stuff like this eventually? Really disgusting rational equations. We're eventually going to do those, and to get rid of the, you had to multiply through by the least common denominator. So we're just reviewing that concept with numbers because we don't want to deal with these yet. Okay, so back up here, a common denominator. It's kind of a pain in the neck because 84 is kind of a big number. Can you tell if 4 goes in there? Seems okay. Does 3 go in there? Anybody remember the trick? Math team trick? Add 8 and 4 is 12. Does 3 go into 12? Yeah, so that means 3 will go evenly into 84. All right, so 84 is going to be my common denominator. Everybody all right with that? This has a 1, common denominator 84. All right, now, I would normally be really lazy, but I'm going to go ahead and write the 84 multiplied by each of these, just to make it clear what I'm doing. All right. Now, 84 times n is just 84n. Here, anybody help me do the mental math? Anybody know what we could do to shorten that up and do it in our heads? The 4 goes into 84 21 times, and 21 times 5 is 105. Okay, the 3 goes into 84, oh, help me, 20 what? 8, thanks. And here, 84s would just cancel, and we get, was it 199? I can't read my own writing. All right, now is this a problem you could solve? Okay, I'm going to stop there because you guys, most of you don't even have this problem, or unless you're writing it down, but you could finish. It does say on this section of the quiz, it says leave your answer in exact and improper, reduced improper form, or a whole number if it happens to come out nice. Okay, so read directions carefully. All right, I'm definitely not doing this bad boy, but I'm going to just start it for you because I want you to know that when you see this, you want to distribute before you worry about the common denominators. And when you distribute, you multiply top times top, bottom times bottom. Are we good? I don't know what 23 times 9 is. 7, carry the 2, 207 maybe? Over 10, x plus 23 times 17. Who's helping me? Thank you. Over 5 times 8, which is 40, minus, now we're not distributing anymore. Okay, what would the common denominator be if we wanted to finish that disgusting problem? 40. So when we multiply through by a 40, this is really only going to get multiplied by a 4, because the 10 is going to go in there. Multiply that one by a 40, it's just going to be 391. Multiply this by a 40, 8 goes into 40 what? 5 times. I don't know, that's, I usually forget the x when I write that down for the next step. That's where I usually go wrong. And if I multiply this guy by 40, it's just that negative 307. Okay. Ready to actually do a couple of those beginning to end? Can you look at worksheet 3? We're just going to do the evens because tonight's homework is going to be to do the odds on worksheet 3 and 4. Now, don't hate me. How many of you already did some of worksheet 3 and 4? Excellent. And you probably did more than just the odds, right? I'm just going to check that everybody's done the odds tomorrow or attempted the odds on worksheet 3 and 4. If you did more than that, it's great practice. I think you can handle this one. What do you think? Okay, let's try number 2 together, though. What are we going to multiply through by? 12 would be a good common denominator. We could use negative 12, but there's really no point. Let's go multiply through by a 12. Can I just write it up here, guys? To remind myself I'm multiplying each term by 12. Then how about if we use our calculator? 12 times 1 divided by 12 is going to be 1, but there was a negative out there, yes? Okay, 12 times 3 divided by 2. Or 12 divided by 2 and then times 3. It's all the same difference. It is 18, and that one has an n. Don't lose your n. Okay? 12 times 7 divided by 6, or easier yet would be 12 divided by the 6, which is 2, times the 7 is 14. 12 times 3 divided by 2 is 18 again, but that one doesn't have an n. Now, we could, in theory, have added these like terms together, right? But to add fractions, we have to get a common denominator. Does that sound like a good time? If we just multiply through and get rid of all the denominators, I think that's easier, and then we'll go from there. It'll work either way, though. This adds up to 32, yes? I'll write that step out. Then if we subtract 32 over here, we get negative 33. We divide, and that reduces by 3, maybe? Negative 11 over 6 would be the reduced improper fraction that it would ask for. I see clapping. Yes, high five. Some of you have that one right already. Good job. How many of you had tried it and put down a decimal? You probably have it right, but go back and change it to try these by using the least common denominator, doing the fractions, okay? Let's do 4 together just to practice one that has distributive. Remember, this is a 4 over 1, and we're distributing it to a 23 over 6. We could reduce the 4 and the 6. Do you want to do that, or you want to just leave it? Just leave it? Okay. 23 times 4 would be, what, 92? Did I do that right? And on the bottom, 1 times 6 is 6. Okay. Then we have this 4 over 1 times 7, which is, do we just leave it minus 7? No, it's 4 times 7 is 28. And we're done distributing. Okay. Common denominator? The way we have it written is 6. If we reduced this, it could have been 3 for sure. It won't matter in the end, I promise. Okay. Do you want me to do 6, or you want to reduce this and make it 3? Anybody care? You want to reduce this and make it 3? So this reduces to what? 46 over 3? And now we've changed our common denominator, can just be 3. I'm going to write this out again, so I don't want anybody to be confused. Now, when I multiply through by the 3, it's just going to get rid of the denominators, right? Because they're both 3? Kind of. What do I have to remember? Do I have to multiply that guy by 3 too? Yeah. All right, so this 3 will divide out. We get 46v minus 28 times 3, 84 maybe? And over here, these 3's will go away, get 284. Add 84, divide by 46. What are we getting? No, I can't add. Is that right? Did I do that part right? Okay. When I divided, I have to tell you, I got really excited earlier today. I went, oh, well, those are both even. So this is 184 over 23. And then I stopped because 23 was prime. I thought I was done. Everybody's like, no, that's not the right answer. That's because 23 goes into 184, right? Does it come out 8 or 7 or 8? So you're always welcome. I'm not going to take your calculator away from you, okay? You're welcome to do use your calculator. So you can use that math enter, even if it does just reduce, right? I am, though, going to tell you have to use one of my calculators that day, and I'm going to make sure that there's either no programs or the programs are locked, because I know some of you have programs or can get programs, and I will give you the program when we're done with this concept, that does distance, midpoint, slope, and equation of a line. Okay, so I'm going to make you do it without. Yes. But yeah, I'm probably not at a point where I'm going to test on that anymore, but yes. Same with quadratic. There's a program that does quadratic formula. The first time we're assessing on it, I'm not going to let you use the program, but eventually when we're just doing like application problems and stuff, you can totally have the program. All right. And then where's the next one you're worried about? Do you think you can do the 10 and 11 kind without too much help? Write the equation of that line? We didn't really do any like that yet, but can you tell me what the slope of number 10 would be? Yeah, because it's going down, right? It goes down 4 and over 4. So that would be a change in y over change in x of a -1. Yep. And what's the other part of the equation? So he's right, it's -1x if we're doing slope-intercept plus what goes back here? Yeah, where it crossed this b is down here. It's crossing at -4, so we could just put -4. And someone raised their hand so politely and asked, do I have to have that -1? You could just write negative x, right? The opposite of x. Well, anything equivalent is good for me. All right, that brings us to the kind of problems that we're going to talk about today. I'm flipping over to worksheet 2. All right, first of all, let's see how fast we can go through these. Tell me one that is for sure a linear equation. Y equals 2x minus 7, you feel pretty confident that that's a linear equation? Yeah. Says in the directions, anything that can be written in either y or it's not really directions, y equals slope-intercept form or standard form. We talked about that one a little bit a second ago. Is an equation of a line. So what else? Give me one that's not. Xy equals 6. You don't think that one's a line? If we divide, we get 6 over x. They tried to tell me earlier today that's the same as 1/6 x. What do you think? Yeah. 1/6 x would be x over 6. 6 over x is actually one of these. Do you kind of remember doing these guys last year? Because if you put in a positive, get out positive, put in negative, get out negative. It's called a hyperbola. Yeah. So this one is not linear. Okay. What's another one that's not linear? I'll just draw a little graph here in case you want to remember. 2x squared. Not linear. That is a parabola. Nicely done. What else? Anybody remember that shape? Yeah, it's a half a parabola going sideways. Good call. Absolute value. Remember what that one is? The V. It's the V. All right. What do you think? Any more that aren't a line? Are a line? Confident one way or the other about any of the rest? What do you think about this one? Does that look a lot like that form right there? Yeah, that is a line. We could solve for the y, right? It'd be ugly. We'd have like, I don't know, 3/4 x and 2.5, I don't know, some achy intercept, but it is definitely a line. What do you think about this guy down here? Can I just add the y over to the other side? Some books actually call standard form ax plus by minus c equals 0, because when we do polynomials, you know, like quadratic, it always has to equal 0 before we can solve it and factor it and all that kind of fun. So they write lines this way too, equal to 0. Yeah, that's where that came from. All right, back over here. What's going on? Don't think either of them? Both are? What do you think? Yes. This one can even be written in slope-intercept form where 0 would be the slope, right? This one, the circled ones right now are all functions. This one is a line, but it's not a function because it's a vertical line. Do you remember the whole vertical line test thing? Okay. Yeah, a vertical line would cross this at a certain vertical line, would cross it at infinite points, so it's not a function. It is a linear equation. Isn't it this form? It's 1x plus 0y equals 6. Can that be standard form? Okay. All right. Enough fun with those. We talked about slope yesterday. Here's a version of slope. We talked about this. We talked about this. So we want to write down a couple? What do you want me to write down? Any definition you want to remember? Jay wasn't here. Somebody tell him the formula we use to find slope between 2 points. Yeah, we could just write delta y over delta x. Or we could do like a y2 minus the y1 over x2 minus the x1. And it really doesn't matter. You could do y1 minus y2 over x1 minus x2. What did your teacher tell you the first time she introduced the idea of slope? Every teacher, same thing, rise over run. All right, is that enough ideas for you? There's another line. What do you want to put there? Change in vertical up and down over change in horizontal. You could do y equals mx plus b. It's this number right here is the slope. I don't care what you do. You don't have to fill them all in. Everybody has some ideas on what slope is. That's not going to be a quiz question. We're just reviewing. All right. We talked about this form. We talked a little bit about standard form. Okay. And I just mentioned this, that sometimes they set it equal to 0. Okay. This form, A, B, and C have to be integers. There can be no fractions or decimals anywhere. If we were converting this one to this, yes, I was looking at that too. But it really doesn't matter. It's still integers, yeah. If we converted, yes, you're right. All right. The other thing to watch for here is it says A has to be greater than or equal to 0. So 2x minus 3y plus or equals 8 is standard form. If I had negative 3x plus y equals 7, it's not standard form until I change all the signs. Negative 7 back here. Because it says that the A has to be greater than or equal to 0. Again, silly math teacher rule, okay? Useful at no point in the world, in my opinion, that you have to know that it's supposed to be positive to be standard form. But all right, do you remember using this one? Maybe. Should have done it in geometry and in algebra 2. If you're given a slope and you're given a point, this one helps you make an equation quickly by saying y minus that point y value equals the slope times x minus the x value of the point, and then you could rearrange it if you wanted. Now do you kind of remember point, slope? Make sure you know all 3 of these, okay? Because they're really useful. Now, could I have found the equation of the line without that? Yes, I could have put the y value of 2 in here, the m value of 4 in here, the x value of 1, and then solved that, and it would have said b equals negative 2, and we already knew m was 4. And guess what? If I went down here and I rearranged this, did I get the same thing? Okay. So you don't have to use point slope most of the time, but when you're given a single point and a slope, it's handy. You know where it comes from? Guess what? If I change this and move it over here, what does it say now? Is that the equation for what? Slope? Just the equation of slope? Okay. Moving on. How quickly can you rewrite that in standard form? 2 things have to happen. What 2 things? The x and y have to be on the same side. So what do you want to do? Yeah, it's a negative 4x, isn't it? So if we add it over, it'll be 4x plus y equals 3.5. Why did I not write that on the blank yet? Can't have stupid decimals. We could multiply everything through by a 10 to get rid of the decimal, move the decimals over once, but then it reduces. It's not really wrong, but it reduces. What could we multiply it by to get rid of that? A 2 would work, wouldn't it? We'd just get a 7 over there. So it'll say 8x plus 2y equals 7, and now it doesn't reduce, right? Nothing goes into 8, 2, and 7. Did I lose you? Anybody need to see another example? Yes. Yeah, if I hadn't realized that that 2 would take care of that, what I was thinking was I might just move the decimal over once on all of them, so I could have made it this, and then they would have all reduced by 5. Does that make sense? if you realize multiplying by the 2 was going to get rid of it. Either way. All right, what about this one? Can you distribute and fix it so that it's in slope intercept? Everybody in here can do that. I know you can. Distribute. Be careful. I made a mistake the first time. Those 6's don't cancel out, right? All right, I got y equals 2x plus 12. How did we do? Agreeing, disagreeing? How do we change it to standard form? If we move the 2x to the other side, are we done? Remember this silly rule? You can't have a negative out front. So we have to change it to what? Positive 2x, which changes the sign on everything. You're multiplying or dividing by a negative 1 all the way through. So it's 2x minus y equals negative 12. We have to use one of those rules of algebra, right? Do unto others what you do unto one of them, you got to go all the way through. So if you decide to change the number on one, you got to change the number on all of them. All right, last one, change this one back to standard form. Or to slope intercept. I can't read. What do you want to do first? Get the y by itself, guys. Subtract 4x. Negative 4x plus 7. Ooh, this is disgusting, yes?
Yes.
Divide this and you get y equals, but a negative 4, negative 6 would reduce to a 2/3. And back here we'd have a 7 over negative 6. You could have just written minus 7, 6. I don't want to have to graph that. How about you? Yuck. But if I wanted to find the slope, would that be a good way to do it? I suppose. "30-second candy break. Go." Seriously, we got to keep going, but I know you guys need to move. It's been a long day. All right. We need to finish the rest of the front and all of the back if humanly possible. So we're going to go quickly. All right. A rough sketch of this would start where, probably, for most of us? Yep. Let's label something down here, negative 5. And then it's doing what? Up 2 and over 1. So I did a really crummy job of even trying to... You went up 2 and over 1, up 2 and over 1. Okay, the slope. This form was handy. It told us the slope right away was 2 or 2 over 1. It also told us what easily? Which of these was easy to find? The y-intercept was negative 5. How do you write that as an ordered pair? 0, negative 5. Guys, remember the x-intercept has a y equal to 0. The y-intercept is when x equals 0. So that's what we're going to do to solve for this. To find the x-intercept is we're going to put a y equals 0 into the equation. So it'll say 2x minus 5. We add the 5 over here. Divide, and we get 2.5 or 5/2. Does that seem like about what it worked out on yours? Somewhere between 2 and 3. It's pretty hard to tell when you don't have any graph paper with lines, right? The next question is fairly useless. This format, if you have to graph or find the x-intercept or the y-intercept, are all icky. The only thing I can pick out of that equation easily is the slope. Y minus 1 equals, it's supposed to be, I'm sorry, y minus y1 equals, I'm just writing that's the point slope. The only thing easy to pick out is the slope is 1/2. Otherwise, I'm probably going to want to move the form around a little bit. If I distribute and add 1 to both sides, anybody get 1/2 x plus 2? Okay, so we're going to call that 2. This slope's a little flatter, yes, than the last one? I don't remember what the last one was now that I mention it. It was, oh, it was going up 2 and over 1. This one's going up 1 and over 2. Okay. Like, wait a minute. All right. We found the y-intercept, didn't we? What am I going to write for y-intercept? 0, 2. How do we find the x-intercept again? Of anything, any polynomial, anything. An x-intercept is when y equals 0. So I could do it here if I write 1/2 x plus 2. Now, we had a big discussion about this in another class today because they moved the 2 over there, and then they told me this was 1. Is half of 1 2? No. Be careful. Half of 4 is 2, in this case, -4. To get rid of a fraction, you multiply by the reciprocal, right? So if we multiply both sides by 2, we get -4, 0. Which makes sense for the picture, yes? We're going down 1, back 2, down 1, back 2. So this was -4. All right, one more before we hit the other side. This is the one you could rewrite in slope-intercept form. That'd probably be the easiest way to find the slope. I'm not going to do that, though. Yep, it's standard form, so I'm going to put a 0 in for the x, which will give me what? It'll say -3y equals 12, so y is -4. If I put the 0 in for the y, it'll say 2x equals 12, so I get 6, 0. Okay, 0, -4, and 6, 0. So the x was 6, 0, the y was 0, -4. Now, if I want the slope, I suppose I could rearrange the equation, but if I graphed it already, can you tell from there what happened? What did it do? Up 4 and right 6, which is 2/3. We could have rearranged it. We could have done -3y equals -2x plus 12, and then divide everything by -3, and you'd get 2/3 x minus 4. But we don't have to do that. There's options. All right. The top is really, really, truly review. Do you want me to skip it or you want me to fill it in real fast for you? We can do it real fast? Okay. Linear if it's in y equals mx plus b or ax plus by equals c form. That's right from the top on the other side, right? Point slope. Anybody quote that one for me without looking? Nice job. Okay, what's this equation for right down here? Slope. Okay, we say vertical lines that go up and down have what kind of slope? Undefined, yes. Undefined slope. We used to, when I was in school, we called it no slope, but no slope and zero slope just sound a lot alike, right? So now they call this undefined. The reason is you'd be dividing by 0. Remember the whole undefined underneath, the zeros underneath, anything like that? Sound familiar? Okay, vertical lines have an equation like x equals 3 or x equals any number, okay? Horizontal lines have what kind of slope then? What's the other one? If it's not undefined, it's going across, it has what? 0 slope. And they have equations like y equals some number. because they cross the y-axis. They run perpendicular to the y-axis. All right. So I'm going to do these super fast. If we go 2, -4 is down here somewhere. Can anybody tell me the horizontal line that would go through there? What would its equation be? Y equals -4. The vertical line I heard over here was x equals 2. See that, guys? Look, the x is 2. The y is -4. It's not a big mystery, right? Just a mystery which one's vertical and which one's horizontal. Sometimes you got to think about that. All right. This is the big concept I wanted to make sure we got to today is parallel and perpendicular. If two lines have exactly the same tilt, they are... What happens if they're perpendicular, though? What do we have to do to their crazy slopes? Yes, reciprocals and opposites. Good job. The sign has to change. That does mean also that their product, if you multiply them together, will equal -1. Like 5/7 and -7/5 are perpendicular slopes, right? There's an exception. Vertical and horizontal lines are perpendicular, okay? But general two functions, you have to flip it over and change sign. So super easy. Someone fill this one in. If the line y equal 1/4 x minus 6, a perpendicular line would have a slope of -4/1 or just -4, while a parallel line would have a slope of 1/4, because this slope was 1/4, so it would stay 1/4. This is a quiz question right here, one like this, okay? It says, what's the slope of EF? That's these two. So remember, we have to put the y's on the top. We could do 6 minus 3, and then we do the x's on the bottom in the same order, -4 minus -9, which would be 3/5. How did I do? Someone else get that? Okay. Then says find the slope of GH. Again, do the y's on the top. -1 minus -6 over 11 minus 8. I got 5/3. Did anybody else get that? Okay. I got positive 5/3. If you did it the other order, you'd have -6 minus -1 over 8 minus 11. That would be -5 over -3, which would still turn out to be positive. Okay. Are they perpendicular? Why not? It flipped over, but it didn't change signs, so we have to do neither. Yep. All right, I'm actually going to skip to, let me do 10a. If the slope is 1/3 and it goes through this point, you want to use point slope or you want to slope intercept? If we did slope intercept, you would say y equals mx plus b. So I'm going to put what y value in? Do I know a y value I can substitute in? There's a y, -4. What m value do I know, or slope? What x value do I know? 3. Now I can find b. What's b? -4. A third of 3 is 1. Subtract 1, I get -5. Now can I write the equation? I know an m and I know a b, so I write y equals 1/3 x minus 5. You could have done that with point slope. So I'm going to use point slope to do a different problem, okay? You can always use either one. I'm going to use point slope to do this one, I guess. What do we have to do first to find B? Find the slope. I'm going to go 9 minus negative 6 over 2 minus negative 4 is 15 over 6, which reduces by 3 to 5 halves. Can you just take my word for it and write 5 halves? All right. I said I would use point slope this time. So this is my slope. What point do you want to use? 2, 9? So it would go y minus, what's a y value? 9 equals m, which is 5 halves, times x minus, and our x value was 2. We could stop here if it didn't tell us what form it had to be in, because that is an equation of a line that goes through that point, those points. If it said it had to be in slope-intercept, we'd have to distribute and get the y by itself. I'm going to assume I have 20 seconds left, so I'm going to talk about perpendicular bisector, which isn't on the quiz anyway, so if you don't get to those on the worksheet, it's not the end of the world. Okay, don't have time. Just kidding. All right, work on worksheet 3 and 4 tonight, the odds at least, okay? At least the odds. Yep, if you want more practice, do the evens. If you get to the perpendicular bisector ones, and you need to skip them because we didn't get there, it's okay.